This meeting is being recorded.
Okay, we'll get started. Good morning or good afternoon, everybody. Thank you so much for joining us today on MetalCon Live. Today we are presenting insulated metal panels, insulation factors that influence Girt spacing. And today's presentation is being brought to us by Alex Belisle of Norbeck. Norbeck is a member of the MCA, and they're an incredibly important association in the metal construction industry. I highly recommend that anyone who's interested takes down the information listed on the screen here. You can always reach out to Jeff Irwin, who can give you more information. His phone number and email address are listed on the screen. From what I can tell you, there are some fantastic benefits to membership, so I highly recommend it. Finally, I also wanted to let everyone know we are very close to MetalCon. This is our last week before MetalCon, our last MetalCon Live before the actual trade show. So be sure that you register now, whether you're an exhibitor, an attendee, an architect. Make sure you get your tickets now before they sell out. Just like I said, we do have a special program for architects. So if you are an architect or an engineer, you really might want to check this information out. We have lots of additional education, some really fun experiences for you guys, including a floor tour that takes you around to some of the most interesting exhibitors we've got and some of the most unique new products on the market that you can see. We also have a great new program called Future Leaders. This is a program designed for anyone under the age of 40. And as a future leader, you will get access to a special happy hour. You're going to get to see a special educational session, which is taking place at 3 p.m. in the main theater, being taught by the incomparable Dr. Melissa Furman. So make sure if you're under the age of 40 that you mark that down on your registration sheet so we can make sure you get the special code on your badge to get you access. And lastly, before you complete today's session, make sure that you fill out the survey that comes at the end, and make sure that if you are AIA, you have filled out your AIA information. Without further ado, I'm going to hand this over to Alex. Alex, take it away.
Thank you. So let me start sharing my screen. So hi everyone. Like I mentioned, I will present you today a small training session about the factors that influence Girt spacing in regards to IMP installation, so insulated metal panels. Just quickly, I'm Alex. I'm the R&D Director and Technical Service Director at Norbeck. We are a IMP manufacturer that is located in Montreal, Canada. We sell across Canada and northeast of the US. Like mentioned, we are part of the MCA IMP Alliance, and we also manufacture panels for the walk-in cooler and freezer industry across North America. I'm part of the IMP Technical Committee with the MCA. So today the information that I will present to you is mostly based out of the IBC 2018, which refers to the ASCE 716 for the design loads for the wind loads for the structure design and building envelope components. And before we start with the factors that influence Girt spacing, I will just start with explaining a little bit what are IMPs for those who are not familiar with this product. So basically, a IMP panel is a all-in-one building envelope system. So it's a composite panel that combines two sheet metal that are formed to create the outside face and the interface of the panel, which are normally around 42 to 44 inches wide. And in the middle, we pour an insulating core, which is most commonly polyisocyanurate or mineral fiber or polyurethane. The solution is a highly performance solution for thermal resistance, and it combines all the different main functions of the building envelope system. So a water barrier, air barrier, and thermal barrier. It also brings a lot to the architects in terms of the building aesthetic. So it can be used, it can be provided in different colors, different texture as well. And you can also use the system as a backup wall system and add other type of cladding over the IMP. This product also offers a simplified installation process, so it can help move quickly around the building, installing the panels with smaller installation crew, less steps of installed. And the particularity of that all-in-one system is that it's installed directly over the building structure. So this is why this topic about the Girt spacing is, to me, it's important when it comes to IMP installation over a building structure. Finally, one of the important gain of going with IMPs on a structure is that the panels, by the way it's built, it's manufactured, it offers high level of rigidity that allows for a greater Girt spacing than other systems. If you want to learn more about IMPs, you can look around for the most IMP manufacturers in North America, or you can also go on the MCA Metal University on the Metal Construction website. There's a section for the IMPs. So basically, we'll divide this presentation in 3 different sections. The first one, which will go through the fundamentals of the wind load evaluation, so wind load determination. I assume that for most of you, this will be a refresher, nothing new there. And we'll go, these are simplified explanation. So if we need to dig deeper on some topics, just let us know and we can take that after or on another time. The second section we'll look at the aspect of the panel and the hardware performance that will influence the Girt spacing. And lastly, we'll look at the FM consideration. Of course, there's a lot of exceptions that will change or that needs to be considered when calculating the Girt spacing. So always make sure that you rely on good expertise or engineering expertise when doing Girt spacing evaluation. So if we dig into the wind load determination, there will be different topics. So we look at the risk category of the building. We'll look at the wind speed based on the location of where the building will be installed. We look at the building dimensions, the surface roughness, the enclosure classification, and lastly, the external pressure coefficient. Of course, all of these information will be translated into factors, numbers that needs to be put together with in different calculation to obtain the applicable wind loads that will be considered for the wind pressure, sorry, that would be considered for Girt spacing calculation. As I said, these are the basics of wind load evaluation, but I think it's important to go back to these different items because sometimes we get the perception that people think it can be a lower risk category that what it is in reality, and this can brings a lot of confusion on structure design and application of IMPs on the structure when let's say, for example, that the building was calculated a certain way, and we try to put IMPs over the structure, and unfortunately we're a little bit too high on the Girt spacing than what needs to be. So we need to be careful with that. Of course, the IMP gives good performance, but we still need to be cautious about those different elements like the risk category. So when you look at this, there's 4 different risk categories. So from 1 to 4, the first one, which is the low risk on human life. These obviously these are abstracts of how we describe a risk category. We could have put a lot more information there, but we don't have enough time to go through all of that detail. So the low risk on human life, here the image that you see, it can be like somewhere from a shed or a storage warehouse where there's no chemicals or valuable or people working in the environment. So think about, in case of a failure, is there a risk for human life inside the building? The second one, well, we'll talk about the second one later on. The third one is construction that represent a substantial risk on the human life, or that could cause economic disruption or day-to-day disruption for civilian life, like schools, like other buildings that are used by the public that needs to be remain in function in case of an in case of a failure, or like I will say a tornado or like a high wind event. The fourth category is essential services. So this risk category is the highest. So we just consider all the infrastructure that needs to be to continue operating when there are a catastrophic event. So, for example, the police, fire station, electricity, communication, and also when we look at a building that will store or manufacture hazardous materials. So finally, the risk category that is the most common is the number 2, which is like everything that is not in the other categories. So manufacturing facility, those kind of things. Also, we didn't mention, but if you have any questions during the presentation, feel free to use the chat to ask or to get more details on what I'm saying. Another important part of this information is the wind speed calculation, so evaluation. So we need to find where the project will be installed, what are the applicable wind speed to the project. Depending on where we are, if we're on the East Coast, West Coast, or for example, if we're in New York City, the wind speed will be different, and we need to take this into consideration. So there's a lot of different websites that will provide that kind of information easily, like with a small research. The one that I'm presenting here is the ATC, but depending on the location, you will be access to the different wind speed based also on the risk category that are presented in the print screen that is there. So yeah, note that here, like I said, we try to consider the correct speed based out of the risk category of the building we're trying to design. Another important factor for the wind load calculation is the building dimensions. Okay, so the building dimensions, we group them into different category. The first one would be the low-rise building, so less than 60 feet, and typically the height will be lower than the footprint of the building. The second category, it's high-rise buildings, so between 60 and 190 feet, and the height will typically be higher than the building footprint. And lastly, the last one is when the height exceeds 190 feet. We don't use the same calculation to evaluate those type of buildings. Now, we know where we install the building. We know what are the dimensions of the building. We know what will be the risk category of the building. We need to figure out how the environment will influence the wind trajectory towards the building. So we look at the surface roughness. There are three different level of surface roughness, B, C, and D. So just consider that the urban and suburban areas would be considered like B surface roughness category. And then as you open to more open terrain with a few obstacles, then you will move to C. And then finally, if you're on a flat, unobstructed area, you go with D. Typically, what we see, it's mostly in the C category that will be built the projects, because when you look at warehouses or refrigerated warehouse or manufacturing facilities, they're often close to a highway or in the close to fields and things like that. So you're mostly on open terrain, except if you're downtown New York, for example. Sorry, just gonna go back here. So it's important to note that both building configuration and surface roughness will be required to determine the exposure classification and coefficient. And with that are items that are important to do all the calculations. The exposure classification, we look at the openings on the building. So this is an important part of the information that needs to be considered, because we need to consider internal wind loads as well, wind pressure as well. So if we have, per se, I will say the partially enclosed will be the most stringent from what I've seen or experienced, like partially enclosed, which is the second one at the top right. So if we have like a plain hanger or things like that, where you have big openings on one wall, just imagine that all the wind that can be engulfed into the building when you open the door, and will add an additional pressure on the panels, on the wall system, that will multiply the pressure that is applied to the panel, in addition with the external wind loads. So this factor on the opening, the exposure classification, will help us determine what are the internal pressure that needs to be considered in addition to the external pressure. So we have 4 different categories here again. So open, which is like mostly open structure. 80% of the walls are open. Then we can have partially enclosed, again, like unevenly distributed openings around the building, or plain hanger, or like a warehouse section where there's a lot of loading bays that can remain open when there are high wind loads. Then we have enclosed building. In the US, we consider less than 1% of the building walls are open. There's a lot of other ways to do that calculation. I just try to oversimplify things here, just to give an idea of where easily we can bring the building into a category. But enclosed building, really, there's not that much opening when you look at the different wall surface. And basically, the partially open category, which is like most typically where the building will fall. Another item is the topographic effects. So basically, we know that when there are a lot of planes and not a lot of obstacles, the way the wind will move towards the plains and the hills and things like that will sometimes increase the wind speed, the natural wind speed. So this needs to be taken into consideration when doing the calculation, because we cannot consider that a building, the same building located in the same town, but not necessarily exposed to the same topography will be exposed to the same wind loads. All these items will be considered to provide a GPC and GCP and a GCPI. So the GCP is the external pressure coefficient, which consider the difference on the wind pressure in relation to the building zone. So we will normally consider higher wind pressure at the corners, and now depending on the size of the building and the configuration, we need to consider a certain distance from the corner up to a certain distance along the wall. And the other item that we look into that is the effective wind area to determine what is the applicable wind loads depending on where we stand on the building. The internal wind pressure, like I mentioned, it's linked to the exposure classification. So what type of opening my building is composed of or contains, and these internal pressure coefficient will basically increase the calculated wind loads that need to be used for Girt spacing determination. So this was the first section regarding the wind loads, but wind loads is one element. Now the other elements is how this affects the panels and the hardware that is used to install those panels. So there are a lot of different panel systems out on the North American market, and all these systems are engineered. So panel manufacturers know what are the performances of their system and how they will react under high wind loads, under different fastening design and things like that. So this is what we'll look into right now. So for the panel performance, we'll look into the panel deflection resistance. We'll look into the structural element composition, and we'll look into the fastening capacity. So for the panel deflection resistance, most of the IMP manufacturers will use ASTM E72 to obtain these numbers, which is a standard test method of conducting the strain test of panel for building construction. So basically, what is the test here is that the panel will be put under pressure to find out what's the weak point and where does it break, and what's the uniformly distributed load that is needed to break the panel. There's a lot of different factors, sub-factors that will influence the results. So what's the panel thickness? So typically a thicker panel will offer better results to deflection as it offers a more rigid assembly. What's the adhesion between the foam and the steel faces of the panel? What are the foam properties? Some system will offer higher rigidity, better compression ratio, better shear strength, things like that. What is the gauge of the steel faces? Thicker gauge steel faces tends to offer better performance to deflection. Finally, another item is the surface profiles. So the surface profiles, some will be mostly decorative, but we see that we know that some manufacturers will do thicker or more profound profiles that will help with deflection data. So there are different comportment that we can see with the behavior that we can see with the deflection. So we have an example where we will be single spanned. So the panel is attached at the bottom and at the top, which normally will be the weakest of the scenarios. And the other one is a multiple span, which consider that the panel is maintained along the height with more supports. In this situation, you can see that by the dotted line that on the multiple span, it's less easy for the panel to bend, okay, because it's maintained more frequently. So we tend to achieve higher span distribution with multiple span than with single span. On the structural element composition, when we do the calculation, we will ask, or we will propose different scenario based on what's the structure, what is the structure made of. So so depending on what is it, a steel structure or a wood structure. If it's a steel structure, we look into the girt thickness. Okay, we take into consideration that we work with construction grade steel, but what's important is what's the thickness. Is it like a 18 gauge or a 1/4 inch thick structural element that we're working with? Obviously, engineering and IMPs, we prefer to work with thicker gauge structure because it eases the installation a lot. But sometimes we're facing thinner gauge structural elements. So we need to consider that this will have a big impact on the girt spacing, as we need to adjust the fasteners in consideration with the steel structure. And as the steel structure is thinner, then the fasteners will be less effective. There's also the option to attach to a wood structure. So we'll go with lag bolts or like wood screw. But now another item is it a glulam system or it's a wood lumber system? So these are things that needs to be provided to the engineer in order to get the proper girt spacing. We get the question from time to time if we can attach the panels directly to a concrete structure or a sub wall. Typically, we prefer to have some steel grid behind the panels or over the concrete structure, as concrete surface is not entirely flat, so it can induce some defects on the panel junctions joining and on the overall installation. So the grid structure will the steel grid structure that would be installed over the concrete will help minimize the possible defects. Another important part is the fastening capacity. This is one of the limitative factor for Girt spacing in most of the scenarios. What's important here is that all the manufacturer will offer different clips. Let's call them clips. So what you see on the picture on the right, the far right is obviously it's a clip that have been deformed once we've done some testing with it. But those clips, they are engineered, they are optimized, and they are designed in order to allow for the less clips possible to install the panel, to optimize the fitment in the panel joint. So we want to get the clip that will take the less space, that will be easier to install, that will allow to install enough fasteners, because when you have a little bit more fastener, then it reduces the stress on the fastening system to the structure. And obviously, if you go with too big of a clip, then it induces additional costs to the installation. So the clip is also normally designed to keep the cost competitive. These different systems, like I said, are engineered and they are tested by the manufacturer to find what is the limit to that, and then they will factor in different consideration to bring to get to the design level. Other considerations that are not based on the panel itself, it's what's the width of the panel. So let's consider that if you work with 24-inch wide panels, you can expect to have slightly wider girth spacing because you will have more clips along the way, and the tributary area of the wind that is considered for each clip is lesser than with the 42-inch wide panel. What's the fastener quality? What are the screws? Are they rated? Are they approved for FM installation, for example? And basically, it is important to make sure that the fastener that are used are matching the structure thickness. So all the fastener manufacturer will give data on the pullout when you use the different fasteners with different threads in relation with the structure, or the type of girth and the structure, the thickness of the girths. So typically, when you have a project, it's important to note that the different IMP manufacturers will try to propose the most optimized solution for the project. So the more information the manufacturer have, the better the support he will be able to provide. We're almost at the end, so this is my last slide of content that I have for you today. Like I said, there's a lot of different exceptions that are covered here in the presentation, but one point that is important is when the project requires FM to be designed as per FM guidelines. So FM factory mutual will bring different considerations. So the most important one is that the wind load calculation should be based out of FM 128 wind design, which is really similar to what what we do typically to calculate the wind load in the US, but it is more stringent. And for example, you can look at the bottom of the page here. So it can easily double or a little bit more, but it can be easily double the wind loads that are applied to a building. The installation must be made in accordance with FM approved hardware and FM approved fastening design. So most of the IMP manufacturers will propose FM approved fastening patterns. So that will meet the FM requirement when they conduct the tests. So and when a building is installed as per FM guidelines, then it needs to be made in accordance with these details and also using the hardware that have been used for the testing or that is approved by FM at the time of the installation. Always see your manufacturer's approved details before proceeding with installation for an FM install. So I know that we had a full hour to go through the content, but so basically we were able to cover that in about half an hour. So I don't know if you have any questions for me at that time.
So yes, we do have several questions that came through in the Q&A, Alex.
Okay. Oops.
If you'd like, I'd be happy to read those out to you.
Yeah. So I opened them here.
Perfect.
So I see
okay,
that there
good.
are three. The first one that I see. Please let me know if there's any standard specification available to design IMP other than European codes, or is this limited but testing only? We cannot simulate all the practical difficulties through testing, and therefore design specifications are necessary. Yeah, I know that for the European systems, there's a guideline, like there's a playbook on IMP specification and testing that is almost specifically made for IMPs. In North America, we need to find testing method and evaluation method that are here and there. So for example, if you look for air and water infiltration, you look into AAMA standards or ASTM standard. If you're looking for fire safety, you will look into NFPA standard or UL standard, for example. So you need to go and see here and there what are the applicable standards, and most of the certification parties in North America are well versed. They have a good knowledge on what's applicable to the different panel systems. For in regards to the specification, there is a standardized spec for IMPs on the IMP Alliance landing page on the MCA website that can be accessible, and you will see there all the different testings that are required. And we can take if we need, we can discuss afterward about this item more in detail if you need to. The second question is, from a structural performance point of view, can I provide some comparison between mineral fiber and foam-based panels? I mean, which are having higher strength capacity. The the foam-based panel will typically have better loading capacities. They offer a better resistance and deflection, and also the core is not the core is the compression on the edges of the mineral fiber is lesser than what we have with foam systems. So we tend to have break that happens more prematurely than with foam system. But it's still a really good system, and it meets a lot of other another set of restrictions that we might have on some buildings, like fire protection and things like that. And the last question is, what is unweighted? I'm sorry, I'm not sure I know how to answer that. I don't know if you can add a little bit to that, or feel free to contact me afterward if you want to discuss. So I think I've covered them, the questions. Last of all, I would like to thank you for being with me today. You have my email address here if you have any questions. And also you can visit us on the at MetalCon 2022. We'll be at the booth 1440. So feel free to pass by and say hello to the team and see our product in the real world.
Absolutely. And thank you, Alex, for joining us today. Thank you for this wonderful presentation. I might not be in metal construction, but I definitely learned quite a bit. Thank you, everyone else, for joining us. We so appreciate you taking the time out of your day to be here with us today. And of course, make sure that you register for MetalCon as soon as possible so we can see you there in just a few short weeks. Thanks again, everybody. Have a great rest of your day. See you soon.
Thank you.
Bye-bye.